What about now? Boom. Boom.
There's a new stream. Is it?
Can you hear me? Okay. Cool. So we're back after technical difficulties. I have no clue how much of this presentation you've already heard or seen. So I'm just going to start from the beginning and just kind of like roll through it a little bit faster than what it was earlier. So my name is Zane Starr. I work on the ETC Labs core dev team, particularly on tools, and I'm working on a team that's producing Jade Service Runner, basically a way to build against locally run JSON RPC services or JSON RPC Services Manager with tie-ins and hooks to OpenRPC, which is an interface description on top of JSON RPC. So that's a lot, but I'm just going to kind of keep going. So the next slide, who am I? So basically, I am infrastructure plus tools plus decentralization. So over the past couple of years, I've been working on building dApps. And most recently, I was at Consensus, where I worked on building decentralized science fiction as a lead dev. Prior to that, I've worked on everything from wireless sensor networks to CRDTs and building big data pipelines at Groupon. So primarily, I've been focused on building infrastructure and services. And I'm currently a part of the ETC Labs core dev team, working on building tools to build dApps. Okay. All right. So a question for you out there. How many of you run a full node to use a dApp? I'm guessing that the answer is like 1, 2, but I'm pre-assuming that it is not many. And you have to sort of look at the reasons why this would be. And so there's the space concerns, there's the maintenance concerns, and then as a like dApp user, more than likely you're not going to be able to use that full node connection to connect to a dApp. You can do this through MetaMask extensions and things like that, but the real question is, does the dApp even support you trying to do this? And the answer is probably no. All right. So as a dApp developer, when I was at Celerius and other endeavors, I've always been looking at how can we sort of create this decentralized ecosystem and like perpetuate this ethos of decentralization first. And so one of the things that you don't really want your application, your dApp to look like is this diagram on the left where everything is kind of centralized. All the nodes are on the outside. This computer lives here. And then all the connections kind of go towards this one central hub. And, you know, it's not really decentralized. What you really want is to build an ecosystem that really fosters this picture over here, where everyone is a peer and there are different hubs where people are connected. And like you really have decentralization. There's no central point of authority. There's no central like funnel where all your traffic is going. This is good for many different reasons. Okay, so this is great, and we want to create this decentralized ecosystem, but really a lot of the problems that we have center around just basic usability. And so imagine trying to get your user to do what I just attempted to do here. And so this is just like a screen capture of me opening up term and just saying, okay, I'm just going to fire up geth or multi-geth in this case. And, you know, I get one of the arguments wrong, And then, I know how to debug this. I know like what's missing and to interpret like the data dump. But your normal everyday user is not going to be able to do this. So really, the bar for fostering this decentralized ecosystem is up here for users when it should be down here. And so you have to sort of look at like, how do we make the bar lower? All right. So what we're always looking for is like a that was easy button. So you can imagine that you had a button that you could hit as a user that launched the service and created this for you, that you could join this decentralized network. And so by doing this, there are a lot of different things that you can do that would ease the burden on the developer and the user side. So on developer side, you'd like to do this, but like there are many friction points into getting the user's local connection information, making sure the service is running, it's the right version. These are just barriers to like you actually allowing your user to run their own local service and to have a good experience. And as a user on your side, it's just a pain in the ass, basically, to open up a terminal, install the right version, and then see that it's running or not running. And then to find out that the dApp that you really want to use doesn't even really support you using or running your own local service. So I want to show you how we can make this better and really like solve some of these low-hanging fruits to make a better decentralized experience for your users and to sort of build the ecosystem that I talked about before, this diagram here where we have many peers in this decentralized network. The users have an easy launch service that allows them to be a part of this network and really like embrace decentralization. And so what we're calling it is the Jade Service Runner, which is basically a JSON RPC service manager with hooks into OpenRPC. Okay, so I'm just going to kind of start talking about like what we want to do and like sort of why and those motivations and walk through that. So we have to ask what happens when we give our user just a simple binary that they can install and just have a easy way to launch services or manage them. So in this case, what we have is an instance of Jade Service Runner running in a toolbar, just as a like sort of illustration of what that would look like. Okay. All right, so why are we trying to do this? I talked about this earlier, and it's like installing services like multi-geth, parity, etc. It's complicated. There are many different steps to that process that are just needlessly complex for the user. So finding what client to install, making sure that the thing that they've installed is the right thing. So they went on Reddit, they found some client, they downloaded it, it just steals their private key. Who knows? So you want to sort of have this ecosystem of trust and like confidence that you're installing the right thing. And then you also have to just run the installation process, which in many cases is not trivial. So a lot of times you might have to go to GitHub, you might have to go to releases page, you might have to install it, you may have to untar or unzip or run the executable. And then on top of that, we're asking users to basically launch the service with ARCs. So a couple of slides ago, I launched the service multi-geth, but I had a series of args I needed to pass in order to make everything work. And I knew how to do that because I'm a dev, but a normal user wouldn't normally know how to debug that. And if it didn't work the first time, you're going to have a hard time convincing them to continue along this path. So why do we want to be decentralized? Well, for many decentralized services, having a lot of peers is like a very important aspect of the security and reliability of the system. So like for in blockchain instances, having a diverse set of peers means that it's harder to consolidate all the power in the network or to do bad things on the network. So for instance, on blockchain, the more validators you have in a network, the less spammy it is because those validators can say, oh, this block is not valid, and they can just kill it in its track and not forward that block along to other clients if you were various like white client configuration. So bottom line is that we need peers. And what are we going to do about that? So, all right. So what is the tool, what is Jade Service Runner like proposing to do about the previous things when it comes to installing services? So we have this toolbar app that you can click on, it would launch. And what does it do? So Jade Service Runner basically allows the dApp developer to request access for an app, install services for that app, and then to get that configuration and then to run that app for the user. So for me, this is very analogous to the way that your phone works. There are many different like applications on your phone. Let's say your iPhone, and you have the App Store, etc. You download the app. You don't know exactly where it goes on your phone, but it goes in a place that makes sense. And you launch it. The app may request permissions. Like in this case, this is the dApp. Do you want to allow it to do multi-geth things? Do you want it to allow it to have access to the RBC port? All these sort of things that you can sort of wrap in and bundle and make easy. So by removing this whole like find the installation, etc. part from the user's hands, we ultimately give control to the user while also allowing the developer to really like grab onto what's going on locally. So we can give information, which is like a thing that's sort of missing from tools today. So basically, again, just to reiterate, the user has to go through this currently right now, but we want to translate this into something like this. Okay. All right, so how do we propose to take advantage of Service Runner, connect to local services? So at a high level, this is just a quick sort of dirty diagram, which isn't exactly true life, but we'll get into that when we go through an example. So here you have the dApp, which could be hosted on IPFS, it could be hosted on S3, it could not be hosted at all, it could be going from an Electron client, or it could just be a JS page that you sent to your friend. And then we have the Jade Service Runner. So Jade Service Runner has a client, which is embedded in the dApp. And then Jade Service Runner is also a standalone sort of application. It could also potentially run in the browser, but that's another story. We're going to just kind of focus on that silo of it being a standalone app. And then on the offside, this is running on the user's machine. So here we have a bunch of different services. We have classic geth, we have multi-geth, we have parity, we have Ethereum, and any sort of open RPC supported services. So the way I see it is that there's decentralization as a theme. And so if you want to start building sort of infrastructure, you want to start building services, how do you get users to become peers? And so the Jade Service Runner could be a part of that by exposing open RPC APIs to users that are more than just local. So regardless of that, it doesn't have to be a blockchain service. It just needs to be a service that wants to communicate with JSON RPC. Maybe even in the future, GraphQL. So the dApp makes requests to Service Runner relays information about what services are running, the status of that, and then it goes back to the dApp. And that's pretty much so it. And so the benefits that we get from this are health checking, proxying requests, service discovery, automatic installation. We do permissioning, and it even opens up the door for doing sort of peer-to-peer peering. Okay, so now we're going to kind of just step through what this tool looks like. So Jade Service Runner is written in TypeScript. And so what this is just what does the process look like from a dev perspective. So here we've installed the Jade Service Runner client. We have this instance, we're creating it, and then we're just going to install a service. Installing service is as simple as this. And you see we get nice typing because we're using TypeScript. All right, so now we've installed multi-geth with version 1.9. And the next thing we're going to do is just start the service. So this is the request part of requesting access. So here we're saying launch the service multi-geth, the 1.9 version, and the environment Kadi. So we specified what exactly we wanted to connect to. So you can imagine you have a dApp, it's on the testnet. How do you connect to it? This is how you would do it. The thing we get back is a configuration. So finally, we're kind of at the end of this loop, and we have the connection information because we've requested the access from the user, and now we want to do something. So what we've done here is that we have pulled in the Jade Service Runner client, but we've also pulled in Ethereum client. This could also be Web3.js, but we believe in open APIs and great documentation and tools and things like that. So what we've actually done is use the Ethereum JSON RPC spec, which there's currently an EIP out, where we can use these open RPC spec documents to really nail down what makes an Ethereum client. So what the Ethereum JSON RPC is just basically an abstraction or extraction of all the features across parity, multi-geth, geth, that are common and core to making an Ethereum client. So this is still in the EIP phase. So it's not 100% official, but we have an OpenRPC document spec. And then I'm going to touch on that a little bit later as to what an OpenRPC document is, but you don't need to know all that. Main thing is that it's a client that we can connect to. So here we've got back the multi-geth. We did a little trickery with types. This is a string, but it should be an integer. And then we just pass in the client connection information that we got from multi-geth, from the service runner. And then we just instantiate the client and we start making calls. Again, TypeScript, with our tooling, we're able to get types and type ahead so we know what we're passing in. And it just works. So with those three sort of components together, you can have this sort of rich experience where users are building locally. Or not building locally, but running locally with very low overhead. So, all right. So next, we're going to try and step into some code. So I'm just going to leave the screen here for a second or two. I would drop this in the chat. If Dev or Ankit could drop this in the chat, that'd be great. Cool. So basically during this portion, I am going to step through some of our tooling and some of the things that we're thinking, and then you can sort of follow along. And it's going to be a semi-live code demo, so it could fail, whatever. We're just going to roll with this punches and see how it goes. Okay. All right. I am going to assume that most of the people online are connected and ready to roll. Oh, I've been told to pause, so okay, I'm going to pause. Okay. Can everybody see my screen? Is that correct? All right. Actually, I'm going to do this because I kind of need to do this myself. Okay. And Slack. Okay. Let's see if I can't switch. course. Yeah. All right, cool. So sort of getting started here. First thing we're going to do is install the Jade service runner itself, the project. Okay. And so what this is this. Oh, okay. Let's just zoom in for a second. Cool. So what this is just the Jade service runner server. And so we're just going to pull this down, just copy it into a terminal like this. Actually, going to copy it in a terminal. Cool. Just like so. Just expand this so you can see. So basically, the Jade service runner here is using some of the tooling from OpenRPC. So I'm just going to pop into this, which is really quite fantastic. So server.js. So underneath the hood, the Jade service runner, in order to be a server, is a JSON RPC like server, but the implementation that we use has strong typing, and so it makes it really nice for making JSON RPC requests. It also plays well with this OpenRPC specification. So just a lot of good feelings and vibes there. All right, cool. We've installed the Jade service runner. Let's see what happens when we run it. Yep. Cool. So we have configs, we have tests, we have directories, ports, help, version, all that jazz. Let's just check the version, make sure. Run the latest version. Boom. 1.1.0, it's the latest. Okay. So now let's go through what else we need to do. So here I just have a little service runner example here. Let's go here. So it's this. And so we're just going to clone this and bring it down. Let's go. Think. Okay. Sorry, just got to find the right directory. Okay, cool. So now we're just going to clone it. Yeah. Probably can't see my screen. Scroll up. Okay. Okay. All right, cool. So we're just gonna get cloned. All right, so we've cloned the Jade service runner, and now we're gonna open this up. See what we have. All right, so here we are. So here I'm just using VS Code. We haven't installed anything. This makes sense. We have some red. So let's go ahead and get into this. npm install. And so you can see here that we have basically pulled in the Jade service runner client, which is in our package.json. Let's actually step through that. So here, package.json looks like this. We're going to start a Jade service runner. We're just going to kind of do a bootleg start for the client. It's not a big deal. And here we're going to pull down the Ethereum JSON RPC spec, which is what I was talking about earlier. And then the Jade service runner client, and then this ETH.js here. So here we are. All right. So now we've installed. Let's see where we're at code-wise. Code-wise, we have the service runner client, Ethereum JSON RPC. And what we kind of want to know is how do we get to where we're trying to go? And where we're trying to go is we just want to show balance from Ethereum account. And we kind of want to know how we do that. So let's just use the tooling and jump in. So let's go on to start. Okay. So the first thing I'm going to do is try and create an instance of the service runner client. So let's do that. All right, so transport. So because we're using TypeScript and typings, everything is like nicely typed. We know what we're going to do and just kind of auto-complete your way to success. If you haven't downloaded the TypeScript VS Code plugins, I highly recommend it. It's really great. Okay, so the first thing we kind of have to do is connect to the service runner itself. And so it's just going to be running on localhost because, again, we're talking about running local services. Let's assume that it's local. And then the port. So this is a bit of trickiness that I actually glossed over. So right now, it's just assumed that it's going to run on the default port, but we haven't really come up with the right protocol for how we want to handle port discovery for just like the service runner itself. But for right now, it's just going to run on a default port, say 1002. It's not that different from assuming that your Ethereum instance is running on localhost 8545. Okay, so we go here and type. So what type is just basically specifying how we're going to talk to the service, and we're just going to talk over HTTP and just keep it really simple for right now. So there we have our instance of the service runner. The next thing we're going to do is take the service runner, and I think like in this list, we kind of want to request that you install the service. So install service is going to take the service name, and we're just going to call it multi-geth. And then version, let's say 1.9.0. Okay, cool. So we've banged this in. Okay, service runner. Cool. Well, no, we're going to do this. Let's just say success. So I know this returns back boolean if it's succeeded or failed for some reason. That's success. Then, well, let's do this. Let's say if not success, just easier. All right, yikes, real monsters. Cool. Okay, so everything we need to know here is this async function, so we should await. Await service runner. Okay, so what do we want to do? We basically want to start the service. So we're going to fill in multi-geth, and then we're going to say version 0. And what do we want? So we want to specify the environment that we're launching in. So if you think about it, when you're interacting with dApp, you need to know sort of what network you're on, what environment, and different environments have different sort of use cases and different sort of functionalities. So you can imagine that you want to run multiple of these services, one in, like, say, Kadi, another in Goerli, and another one on mainnet. So like maybe you have some experimental features. Well, using a service runner, you can have all of that for your user. You know? So here we go. We have multi-geth. We have the version. I'm saying I need an environment, so environment's dev. And I'm getting ready to step through where I'm getting all this information, but for right now, we're just going to focus on trying to get to there. So multi-geth, config. All right, so we have the multi-geth config. All right, now what else will we need? So now I have multi-geth config. I have the service runner started. And the next thing I'm going to need, well, maybe it's even useful to just run it and watch it fail. Let's run it and watch it fail. So go to terminal. Okay, so earlier we installed the Jade service runner, so I know it's there. What happens if I just say Jade service runner? I'm going to do this thing. So you could run into an error. Maybe it's going to manifest itself here, which has to do with the length of the path name. It's kind of obscure. It just happens to be on this nested folder. The service I'm trying to run is a little bit complicated. So maybe I'll just run it and you'll see it. So here we just start the Jade service runner with the default config, nothing fancy. And then we go here and let's say, let's run the build, npm run build, and no, we don't have anything yet. So let's do this. Cool, we built, it was successful. And since this is TypeScript, we're gonna do this and see what happens. So we did this, we started service, it's installing. Well, I should have probably added a printout here. Let's do that. Console.log, multi-geth. Let's just make sure we have something. Right. So here it's installing. Cool. Cool. Ah, it installed. So one of the features of that is the progress bar. But according to logs we've run, we've installed, it was successful. So let's just go back and just run it again. Okay, cool. Oh, and it looks like we started our dev node. And you see this here is actually the area I was talking about, because the path is so long that there's like a limit on the service start. It's kind of obscure, but we can easily work around this. So if you ran into this while you were trying to execute, I'm going to show you how to fix that. So really all you need is a shorter path. And so if you can see this is the output from one of the configs. So what it returns back is a resolved config. So this, we have a bunch of dynamic configurations as to like what port to bind things to. So what you have here is the actual port that was resolved by the software. So we'll step back into that if we do this. So let's go help, see what we need. We need to specify the services directory. So we do this. Says 3. I have a bunch of services things, so it's kind of cool to just start clean. And so what this directory really is a repository. So within this repo, it specifies where the services are installed. And inside of that, there's a manifest file, which specifies what was actually installed and where it lives and what version it is. So if you want to do an upgrade or you wanted to verify that something exists or doesn't, it's like drop that easy to do. So we launch the service again. We're going to do this one more time. Maybe we'll do something a little bit nicer and just stringify this. So I think it's JSON stringify. And the value, let's do this, null app 2, I think. Is that correct? And run. It's going to be another like sort of nasty long output. But what we should see, we have to reinstall because now like my repo is different, so it doesn't actually know that there is a service installed. Okay. Wait for it. Okay, so while that's going on, I'm just going to do a little Martha Stewart switch over. And we are going to go to Jade Service Runner. So I was specifying a lot of environment variables, and there's a lot of questions as to how I like sort of knew about the config. And so right now there's not a good like sort of service discovery for the service runner, but internally underneath the hood, there's a rich structure that supports the configuration. And so I'm just going to step through the actual configuration for the service runner here. So actually, wrong path. This is what I'm looking for. So here we have the service runner config, which looks like this. So this is the service runner config. And so basically, each service has a service description. The description includes the name, the RPC port that you want the JSON service runner to connect to, the version, and the environment. So back in the example, we had a specified environment of dev. So let's just go ahead and take a look at dev. And the service was multi-geth. So we're just going to search through this for dev. All right, dev. All right, so we're in the environment. We have dev. Here are the arguments that I'm going to start the service with. And so these are just sort of Oracle-based parameters. So in the future, we'll have third-party services that are able to request to add services to your config. So you can authorize a third party to, say, run their own environment, or you can convince the users to just run their own environment through a service config extension, which is the method that works now and something that you would use in dev. And I'm going to step through that as well in the second part of this. And so as we're going through this, we have this variable arg service dir. So when you see this is a variable arg. And so the service runner underneath the hood will dynamically fill this out. And so this is a services directory that you specify in order to say where the services are going to be stored. And this dynamic TCP port, which is filled out by the service runner itself. So it will search your computer for a free port and then assign it that port. So you can use this across your configuration. So it's not bound to any one specific port, but the service runner knows what port that is, so it can map it. Then we have health checks. So on the order of milliseconds, how long does it take and how many retries you need before it will reboot. So in this case, it's a TCP. It works like AWS Classic Load Balancer. And so it will just flip the service if it's not running or if it timed out through socket connection failure. So it's like a soft failure restart. Okay, and so the other thing here is to look at the OS config. So we're running a service runner across multiple different services, so Windows, Mac OS, Linux. So you need to have particular configurations and binaries for each of the services that you're running. And so this just kind of walks through that. So for OSX and multi-geth, you have to chmod the geth, and then which is part of the setup sequence. And then you need to download this particular version of the software and OSX. So in the future, we can do verification checksums. We can do code signing to say, like, this came from the source of authority or where you expected this asset to come from. And it looks like what you expect. But for now, this is the easiest way. So we did all that work to install again, and we're just going to go back to where we were. So I think here. So now, if we check our inner node, it seems like everything is running properly. We got rid of that error. We have an actual address that's filled out by the dev environment. So now, if we want to connect to something, we can. So let's go ahead and just make this happen for us. So here we could either take a variable argument or we could pass this in. So let's add this address here. So E2, question mark. Let's do, what am I doing? Here we are. And boom. So if nothing's specified, use this address. Cool. So we're now ready. We've started the service. It's been installed. We debugged a few things. We kind of stepped through how we were getting this configuration and how it was getting passed up. And so now we want to configure our actual Ethereum client. So you could use Web3 here, or you could use this Ethereum JSON RPC client. It just depends on what functionality you need. In this case, we're just going to go for a very broad Git balance. So this new Ethereum JSON RPC client, we're going to do that. And we're going to see what it takes. It takes transport. Oh, it's the same as client.js that we're using for the service runner. So host, we're going to do localhost. And then the next thing we're going to do is add the port. And, well, what port are we bound to? So earlier we made this essentially 8002, but we're relying on the service runner. So as a dApp, and if you imagine this running on the inside of your web app, what would you do? How would you find it? So service runner is taking care of that for you, and all you need to do is just call multi-geth port, the RPC port that was specified in the config, which is dynamic. Throw in a parcent, just because the type of RPC port is string, and 10 do this. And we are almost there. Just type, and we're going to pass in HTTP. Cool. So now we have constructed our Ethereum client, const eth client, why not? And let's see what's in here. So eth client dot, oh, snap. We have everything. So we have ETH get balance, gas price, estimate gas, Coinbase, all this stuff. All the things that are essential to your Ethereum client with the types. So we go here. And now we want to pass in the address. So we found the address that was started. And next, we're just going to pass in a block number. So we go 00x0. OK. And what do we need to do? We need to wait for this. Const balance. So we have. And then show balance. Balance. Is this right? So show balance takes a string. What type are we getting back? It could be nullable because this could come back as blank. So I think as how about this? So TypeScript means we have to have a type guard, so we'll just type guard it. Okay. A little more formatting, and let's see. What do we have? It's yelling at me. Type of string, type null is assignable type string. Well, how about this? Actually, there we go. Okay, so it looks like we have everything that we need. And so JS unit from way, let's give this a run. So this is going to call start balance a bunch of times, and it doesn't start service rather a bunch of times, and it doesn't actually matter that we're calling it a bunch of times. Because underneath the code, what the service runner will do if the service already started, it's just no op, return a connection to the active service. So we're going to run it. It's live demo. And we got back a result. It's amazing. It's amazing. So underneath the hood, the dev version of multi-geth will autofill an account for you. And because we passed in this address, which is the dev account that was launched with some ETH, we get back some ETH, and it's mining. And so this is basically, in a nutshell, how the service runner works and looks. And so I'm going to quickly pivot into the sort of more in-depth where do we go from here? And I guess I'm going to also show you one thing about the internals, which is kind of interesting to look at. So earlier, I had this -- Jade service runner dir. Let's go to help. You can see what I'm talking about. So we had this dir to specify this directory. So internally, I think I called it services 3 at the time. there is this, but there's also services team, services. All right, let's see what's done services. All right, so as you can see, there's this Jade service runner manifest file. And so I talked about this briefly, but now we're just gonna kind of look and see like what's in it. And so the thing is that whenever you install a service or you make some modification, what happens is that service and then like what happened with its installation is installed into this manifest file, which has a JSON schema, so it's strictly typed. And it just kind of lays out where the service actually is. So this is saying that like the multi-geth service with its assets is in this particular directory with its version, and like let's just see what's in there. So let's see services. Services. Okay, multi-geth 1.9. And here we have geth process. We also have multi-geth. And then we have some dev-specific things. So you may remember the data that we set up. And so this is actually pointing to that data. Okay. So that concludes sort of this Jade service runner example. And so the next thing I'm going to sort of show you is where the future is going and what kind of cool things can we do with some of the tools that we're doing with Jade, and then how does that tie into Service Runner? So I have this spec or this service called Simple Math. So I'm actually going to go to the playground. It's linked to in the gist. Okay, so this playground OpenRPC is really an awesome tool for looking at JSON RPC documents specified by the OpenRPC spec. So it's great for looking at OpenRPC documents and for sort of developing a language. So one of the things that this team has been really focused on is sort of README-driven development. And so taking that forward, the team, prior to my coming on, had developed a tool for visualizing and quickly iterating and rapidly developing applications. So one of the tools are the OpenRPC Playground, which allows you to play with OpenRPC specs. So what we're going to do is just quickly generate a mock server and a JSON RPC client straight from the spec. So you can imagine that what you want to do is create a new service, a new API for adding two numbers. And so you might start with something like a title, you might give it a description. And the cool thing about this is that it all sort of autofills. So you can do things like this. And let's show you. And say like simple description. And you can kind of get these nice like type ahead features. And you can see over here, it's like updating and tells you sort of what methods are there. So according to OpenRPC specification, which I won't go too much in depth, you can set up a description of an API. So in this case, here's the method addition, which is an RPC method. And it takes two variables, A, it takes a B. These are schemas for integers. So this is following like JSON schema, which I encourage you to look at if you haven't. It's great. It's fantastic for sort of typing JSON, which is actually kind of important for like system stability. Okay. And then you can specify what parameters there are, and then you have this thing called examples. So examples within the OpenRPC tooling is really important because it allows you to auto-generate examples of your code. So you may know Swagger API. This is kind of like Swagger API on crack. So what it does is it will auto-generate the response for you, but it will also take the parameters and give you typings and an interface for you to code against. So it could just auto run. And it's almost there to the full sort of parity. It was great in the fact that you could input the values that you want to test live, but it's coming. So the thing that we're going to look at here is going to be simple math addition 2, where we specify that it takes an integer that's 2, another integer that's 2, and returns a result of 4. Okay, so where I'm going with this is that what we wanted to do was to test the waters with our service that we want to deploy on millions of machines. And we want to have this be decentralized. We want to have peers that are running this code, right? And so what this serves as is the specification or document for anyone that wants to run or write a simple math service. These are the things that it needs to do. And if you do these things, you adhere to the spec, and you have a simple math service. Okay, so we have this open RPC description. The thing that we're going to do is turn this into live working code, and then we're going to run this with the Jade service runner and sort of developer dApp. Okay, so here's what I'm going to do. I'm just going to check out. Let's see, where am I located? I'm going to check out the, let's see, what branch? Yeah, keep going. Check out simple math. Let's stash my changes. All right, we're in simple math. Okay, so let's have a look at this code and we'll just walk through. I'm not going to actually just bang everything out live, but it really only takes like 5 seconds. So what are we doing? What do we have? So we have this service runner. Okay, service runner client. We stepped through that last time. We understand it. Simple math client. Okay, so what is this and how do we get it? Okay, so what we have is a program and a capability of generating a full working client for any sort of JSON RPC based service from a spec document. So let's take a look at this. So I just pulled this down from GitHub. And we have this open, simple math, open RPC JSON. And so this is the service description that defines what are the interfaces and what are the requests that are JSON RPC specific that we need to make to this service, which is the simple math service. So using our tooling, we're going to just generate a client. And it's this simple to generate a client. I'm not going to do it in this particular directory. But I will do it in, well, actually, I might do it in this directory. So we're going to call open RPC generator client. So actually, I'm just going to go through the steps so you can understand. That's G add open RPC and then generator client. And this is all you need to do to install a generator client. So I already have it installed, so I'm not going to go through that again. Just going to open RPC generator client. And then what we're going to do is we're going to specify a document for this to generate the client with. And then RPC JSON. Let's do -d. Cool. All right. So what this is doing is it's going to generate a client in 2 different languages. It's going to generate one in Rust, and it's going to generate one in TypeScript. And so there are going to be n different language client generators for these JSON RPC specs. But just using this one, we're going to generate the TypeScript client, just like so. And then we're going to import that. And then that's how we're going to get access to the service. So at the moment, I've written 0 code. The only thing I've written is this description. Okay? So I'm just going to fast forward, cooking show. And we're going to switch to services, this client. So The client that was generated is this. There are some mangled type names, but this is just an artifact. You can have smart type names, but we had to roll back a change that made it have nice names like integer, string, etc. Okay, so what we have and what's been generated is this client. It's a simple math client. It has RPC client. It specifies the open RPC document, which is the thing that we had there earlier, and says like what it should do. And it includes the examples such that we can make these requests. So it has the entire description that we played with in the playground, and it has a description that's in GitHub and is in my local machine. And then here are a bunch of transports and stuff like that, and stuff that doesn't really matter. The most important thing is that you get this nice, strongly typed interface to code against. And it's always in sync with the spec. So there's not gonna be a discrepancy between your documentation and what actually happens on the machine. So we're gonna go back here to index. So now we understand what this is doing. It takes a simple math. You have this object, you're happy, you got everything you want. You're gonna list the running services, see what's going on. Simple math is not gonna be running. It's just the way it is. And then what you're gonna do is install simple math. All right, hold the phone, wait a second. So how are you gonna install simple math? Simple math doesn't exist. It's not a service. You just have the spec and you generate a client, but every client needs a service. Needs a server. Every good client needs a server. Okay, so you have this, and so you wanna know how are you gonna generate the server. So here's another awesome tool within the Jade suite. I'm just kind of like crushing on all of this. So I might as well like use it. And I figured if you're gonna do something really quick and you wanna do something in sort of 5 minutes or as little time as possible, let's see if I can find this. So the thing that we're gonna use to generate the server is this OpenRPC mock server. It's still like heavily under development, but it basically takes an OpenRPC document and will generate a server for you. So if you run mock server will take this specification and then it will launch the RPC service that corresponds to that specification and then pull that in with the examples. And that's just like, it's great. It's fantastic. I'm really jazzed about it. So what this means is that you can come up with an idea for a service and then instantly test that and not have to worry about how you're going to manage the connections. A lot of the scaffolding is just like done for you. So what this is going to do is it's going to install simple math. It's going to start the simple math service and go forward. So earlier I mentioned this extension config. So what we're going to do is like specify the simple math service. And so we're going to just like step through what it's going to do. So I want to add a service to JSON service, Jade service runner, right? How am I going to do that? So excited, can't even talk. So we have simple math. So we're going to name the service simple math. We're going to specify the RPC port. There's going to be a dynamic TCP port. We're going to then name the environment, which is going to be dev. And then here are the arguments we're going to need to pass the mock server. So actually, let's just figure out what the arguments are and just make sure that we got them right. So OpenRPC mock server. So if you want to install the OpenRPC mock server, you just npm install g at OpenRPC mock server take off. There we go. All right, it's installing. Cool. We've seen it. Cooking show. So we have this. And mock server didn't work, of course, because it didn't pass the args. Look at the mock server. So you have the start, which is -d. You specify where you want the service to live. And we want the service to live in the service directory. And in the service directory, we have this asset called simple math. And then you're going to specify the port that the service is running on. And so we want the service runner to be in control of what the RPC port is. So we say, give me a dynamic port, I don't care where, make it live. So we go through this, and we realize we also need to specify what we want to have happen for each OS that we want to support. So we're going to support OS X, and we're going to support Linux. Windows does work, but there's some like testing issues and some like finickiness that like, needs to be sort of worked out. So the cool thing about this is that you don't actually need a binary to even like, really do this in a dev sort of environment. If you know that NPM exists, then you can kind of cheat. Normally, if you had real services where you had binary, it could be in Go, it could be, I've even written these in like bash scripts. Like internally, test, I use bash. So anyways, or PowerShell for Windows. So npm install -g, OpenRPC mock server at latest. Cool, and this is like the setup command that gets run. The next thing we're gonna do is just have our start command, which is just gonna be OpenRPC mock server. We installed it globally, so it should just run. And the assets. So earlier we had multi-geth. Multi-geth had an asset for OSX. In this case, the simple math asset is just the zipped OpenRPC document. So it has to be a zip file right now for like, stupid reasons. But otherwise, you could just specify any sort of asset you want. If you have multiple assets, you can just add them into the chain. It's an array. Cool. All right. So that's what the JSON service extension looks like. All right. So what does it look like when we want to run this bad boy? So let's see what we have. I have like 5 of these. Which one's right? So I had to do a little bit of finickiness for this because it just kind of came together last minute. So I'm just going to have to search for it. All right. Well, anyways, I know how to do it, but it may not work in this particular context. So what's that? Okay, so here's what I'm going to do. I'm going to specify a service runner extension. So the extension is the extension that like we just stepped through. So this is going to say like where the service is, how to get it, how to install it, how to run it, how to shut it down. So we're going to do this, and then we're going to do this other cool thing. We're going to specify the directory that we're going to run it. So maybe I'm just going to do -ster. I can't remember if I called it D or dir. Okay. All right. Go, go, go. All right. Cool. Service runner is started. It should have the service runner simple math extension. And so the thing that we're going to want to try is to run this code. So tsc npm run build and build nx.js. All right, cool. So what happens when we run this? Oh, terrible. So we had an error. And so we want to see sort of why. And I think it is, I ran into this a little bit earlier, so I knew this was going to be a little bit testy. So I think I already have an example of this running good to go. Just need to figure out what window, unfortunately. Yeah, this one seems right. And I think it's just because I have the service runner running in the background already somewhere. So you can't run multiple of these at the same time. So just bear with me. And we're going to get this going. Okay. Okay. So I'm just going to start closing out the ones I know are not the right one. I think this is the right one. So, yep, it is. So let's fix that. And one more process running in the background, I'm sure. All right. All right, now I'm just going to look at this here and see what happened. Okay, could not start service runner. Maybe it has to do with my directory. Could not start service runner, of course. Okay, well, let's just get a clean directory and then we'll just debug. Make sure, okay, that seemed fine. Now let's do the extension. Might have been the directory that was in. Let's just have a look. 5 examples. Yes. Get branched. That's why. All right. We'll check out. And now I think. Okay. So now we have the service running. There we go. Well, almost right. So what should happen is this will say 4. And so I think this has a corrupt JSON file. So if you just bear with me one more second. We're almost there. See what directory I'm in. Go up. Up. Okay. Let's go to a working version here. I think. Okay, so we have the services. Let's go to 2 here. No, build X, yes. There we go. So this is simple math. It's waiting 4. So sorry that took a while to get to. But if we look at the code for this, it's the same. It's just I had like some corrupted directories from where I was testing earlier. I didn't get a chance to clean it out. But basically what we did is we instantiated the client. We connected to the simple math client. We installed the service, which was simple math, using the extension. And then we did this thing where we actually just called the function. And I didn't write any code at all for this. The only thing I wrote was the spec and the dApp. So I was able to build the whole entire shell of a dApp from a spec and to have it running reliably and to have it running in a decentralized fashion. So expand your mind for a second. And imagine that instead of just simple math, it did something slightly more complicated. And let's say that each user had their own slice of data. And let's say that we had something called verifiable data structures, something like Trillion and like Google. And so Google's Trillion, rather, where you can then say like, oh, with a certain degree of confidence that this is indeed the historical data that was produced by a particular app. You could use this to then build infrastructure, actual decentralized infrastructure for APIs outside of just blockchain applications. So that's one of the reasons I'm like really excited to be like working on this project and giving the sort of community these tools to sort of foster decentralization. That's just one of the directions you can go for it. So now I'm just going to kind of wrap up and then leave room for questions if there are any. And so here I just kind of wanted to leave you guys with some things for future consideration. Okay, so some future considerations, just bullet points finally. Proxying requests. So earlier I had this diagram, like many slides ago, that showed the proxy, that showed the Jade service runner that sat in front of a bunch of services. Right now, the reality is that I just, we allow for direct connections to services. But in the future, I imagine that we're going to proxy these, and that will lead ways to sort of rate limiting, throttling, tighter permissions control, and the ability to sort of allow other users to connect to them. So what about peer-to-peer services with OpenRPC Discover? So with OpenRPC Discover, you can discover services that are following the OpenRPC spec. So you could go to the service runner, and then you could request the OpenRPC discovery for each of the services that the service runner is running. And then you could create a graph of services that you can connect to build a dApp. So you could be building a dApp off of services that are running on many different people's machines for various reasons. So like trying to push for truly serverless applications. The other thing is abstraction. So earlier we sort of built that Ethereum client, and the Ethereum client is a great example of where we've had some sort of consensus about like what the core set should be of features, and then like pulled that out and then started formalizing that for like sort of an organizational purpose, so that way people can unify on what a service is. But what if you're able to take a JSON RPC spec and duck type that? So you can imagine that what you really want is a shape of functionality. And so there is syntactic duck typing, where it's like, oh, this returns back an integer, etc. And then there's semantic duck typing, where that means like the meaning of these values is also the same. So what that would mean is like in the simple math addition worked on base 10, but imagine that simple math addition, I wrote one that has the same spec that works on base 16. Same shape, different meaning. But these are things that we're considering when we're building these tools to make better dApps. Is that you can then generate clients and have services run, and we can figure out the layer of abstraction that you need to connect to them without locking yourself into any one implementation. And then finally, services registry. So you saw how we extended that and we installed our own like API into the Jade service runner. Eventually, you'll need some way of allowing third parties to do this dynamically. And you can do this through like a service registry, whether that's through a blockchain, a multi-chain, or like IPFS, or just direct to the client. Okay, and so I'd like to thank the ETC Labs core tooling team, Dev, Wesley, Shane Jonas, Zach Belford, and Ankit for helping me put this together. Thank you guys, and I hope you enjoyed this talk. Feel free to get at me at ZaneSeedStar on Twitter, or I encourage you to fork ETC Labs core projects and the OpenRPC. It's really awesome stuff that's going to save your dev life. Cool. That's it.
You sound like a lot of people.
Okay.